In my opinion, my vision is that we need to go faster. If we're going to see in our lifetimes, we're going to see discovery of important breakthroughs, then we're playing not against each other, but against time.
Welcome to Biotech Bites, where we talk about technology with leaders in the tech industry for biotech companies. I'm your host, Steve Swan, and have the pleasure of being joined today by Stavros Papadopoulos, the founder and CEO of TileDB, which is a software company for scientific discovery that helps to structure all data types. Stavros, thank you for joining us. Excited for this.
Thank you, Steve. I really appreciate the opportunity.
Yeah, no, this is great. And I always like starting out just real basic for our listeners. Tell me about you. Tell me how you got to where you are today. How did you ascend to being the founder and CEO of TileDB?
I'm a computer scientist by training. This is the first company that I'm creating. I started off in Greece. This is where I did my bachelor's degree in computer science. And then very early, I left Greece to go to Hong Kong to do my PhD, continuing, of course, in computer science. And this is where I worked mostly with data. It was all data management from the beginning. At the time, I was doing a lot of algorithms and data structures. At some point, things got a little bit out of hand, and I got into cryptography. So I was doing a lot of mathematics, always related to data and data structures and algorithms. After I finished my PhD, I stayed in Hong Kong for another 3 years. I became a professor, so I was very much into academics. And in 2014, I got an amazing opportunity to come to Boston, where I still live, and work at MIT and Intel Labs. It was a dual appointment. I was working for Intel. I was a senior researcher at Intel Labs, but I was stationed at MIT, working with the database group there, one of the most powerful database groups in the world. I had the privilege to work with these folks, and actually, I started TileDB very early on, probably in the first month. The idea got shaped, and we said, okay, let's go and test it out. Well, that was the beginning of everything.
And so you had the idea. Now, did you have partners there, or is this your baby? You did this?
When I started at MIT, I worked very closely with Michael Stonebraker, who's a god in databases. He did so many companies, and he's a creator of Postgres, among other good things. Alongside with Sam Madden, another amazing professor at MIT, some people at Intel. Initially, the ideas were just a research project. Okay, we were trying to understand how to better model data so that we marry the high-performance computing work that was being done at Intel and the database work that was being done at MIT. What kind of data do we want to manage and handle and process and analyze so that these two domains, which look very, very different, they can come together? So high-performance computing is mostly about supercomputing, a lot of cores, a lot of CPUs, problems like computational linear algebra, a lot of mathematics. But this mathematics lies at the core of machine learning and deep learning and other sophisticated operations. But then in the database world, databases are doing a lot of sophisticated operations. And I noticed that those two domains don't go to the same bars, like people from those two domains don't hang out a lot together. And they're two different streams of work. So I wanted to marry those. This is how I started reasoning around data and how to model data in a much more general way so that we can structure any data beyond the traditional tables that relational databases could handle.
That's awesome. Now, so kind of a sidebar, my nephew who does a lot of AI work, and he's working for a startup out in California, he was just telling me that a lot of what's going on now with the AI work is exactly what you just said. We're proving out the theorems with mathematics so the AI can, loosely anyway, reason a little bit better, and he said, think of high school calculus and algebra, Uncle Steve. That's what we're doing. It's, we got to get through it that way.
It's pretty much linear algebra, and linear algebra is about very efficient computations on matrices and vectors, and other people are calling them tensors, multidimensional arrays. We use the term multidimensional array. So, and that was actually the observation, Steve. I was observing that no matter what form the data is in on your disk, be it genomics, transcriptomics, imaging, point clouds, whatever tables, when you bring it in main memory in the machine, and then in the CPUs and GPUs, the data gets converted into vectors and matrices and arrays. So the question, the scientific question that I had at the time was, why aren't we storing this data in this format to begin with, since we're converting into that format to process it? So that was the very deep scientific question that I had. But then the ideas evolved from there, and the question became a little bit bigger. And the question was, can a single database system exist that can deal with all data, with multi-modal data, right? With different types of data, not just the tables, not just the images, not just the genomics, but all of it. And that was the beginning of everything. And we pulled this off with this magical data structure, the multi-dimensional array.
That's awesome. I love that. Yeah, because everything I'm hearing about right now, and you know this, obviously, you're in the middle of it. Everything I'm hearing about is the data, the storage, the retrieval, my podcasts are all these leaders within biotech, right? Big consumers of data, right? I'm both commercial and the R&D side. Mainly the R&D side, that's where a lot of that big data is, and that's where you guys live. But we can talk about AI all day long. But if you're not putting data into it that's decent, that's like not having gasoline for an engine, right?
Yeah. So that was a kind of pleasant consequence for us as well. I mean, AI distracted people a lot because there was a huge hype and very, very quick one. So people got distracted a little bit, and they shouldn't. They should be focusing on data to begin with, and then AI. So first start with the data foundation, then go to AI. But here's the thing, how it helped at least us. When I was talking about multiple modalities at the time, we were talking about 2014 to 2017 when I was at MIT. The company got created in 2017. But during those 3 years, I was trying to tell people, and I was trying to find use cases for a multi-modal database system. So a database system that can capture more than table. In the business world, there was little appetite for multi-modal data. It was all table. It was all tables. Like if you go to a financial institution, they're going to tell you we have tables and time series, mostly 90%, perhaps more. So when I was talking about a multi-modal database system, there wasn't much appetite. We found applications in defense, a lot of geospatial data that are multimodal, but not so much. And of course, life sciences, and we're going to talk a lot about this, but not so much in the business world. And now with AI, everybody's talking about multimodal data because the large language models are multimodal. In other words, those organizations are realizing that in order to gain better insights from their businesses or for their businesses, they need to combine the tabular data with their PDFs, with their text, with their email, with pretty much all the data that the organization is generating. And this is a great ground for us.
That's where you're standing.
Correct. And we are ahead because we've been doing this for 10 years.
That's awesome. That's great. And yeah, it's just amazing to me, all these things that have come to, come to converge on all this right now, So now when it comes to the data, right, here's a question for you, because I've had people say this on my podcast, some members of the biotech community, they'll say to me, I asked one gentleman who's the CIO of a large biotech. He said, listen, we corrected it. We got our data in shape starting probably 2015, 16, right in there, right? So we're good from that point forward. But we got to go back and we got to deal with all our 30 years worth of experimental data and all that stuff. Does TileDB help with that? Help me, CIO of a large biotech with 30 years worth of data that I'm having trouble getting through? Is that something, just so I fully understand?
Yeah, absolutely. Great question. And actually, it's bi-directional, not moving only towards the past, but also to the future. And I'm going to give you an example.
Cool.
One of the first use cases that we had was with the Broad Institute while I was having the Intel and MIT had, not during the TileDB years. And the problem was that they amassed a lot of genomic variant files, right? Genome sequencing data. And they had reached the scalability, not only them, the entire life sciences domain, they had reached the scaling ceiling for handling this kind of data. The data exploded. And of course, they had a lot of legacy data in the past. So the legacy data is typically stored in bespoke format. It's not like CSVs. It's something more complex than that, for sure, more complex. And the data is bigger. So you need to deal with this legacy first. So this is the one direction, moving to the past. Like, how do we deal with all these legacy formats out there? And there's a lot. And when we're talking about multimodal data, we're talking about a lot of formats. That's the thing. If it was one, it would have been easier. We would have focused on one data type and that's it. But the problem is like there are hundreds. So big problem going towards that direction. But also, and this is what a lot of organizations don't understand, and And this pertains to organizations that are building technology in-house themselves for bespoke formats. And this is what I'm completely against. And that's why I'm seeking for universal solutions, not for bespoke. A bespoke solution is limited by time. Like you build it once for the data of your time and of the past time, but not of the future time. We go the other direction as well into the future. And the example here is that genomics was the first use case. So we adapted the TileDB technology, this multi-dimensional array technology for genomics, and it worked phenomenally well. But then we hired an amazing person in our company, a bioinformatician, who came in to work on genomics in one of our one-on-ones very early on. We're talking about 4 or 5 years ago. He says, you know what, like in life sciences, there is another data type coming up a lot. And this is what the big pharmaceuticals are looking into. And this is single cell. So this is like RNA sequencing, right? It's transcriptomics. There is genomics, but also there is transcriptomics. And this is another up and coming super valuable data asset for organization. It took us, of course, we work with organizations like the Trans Zuckerberg Initiative. So we work with luminaries in the space to do this, but we did it. We did it with array. We didn't build a new technology. We adapted the core technology we have, which is arrays, in order to handle single cell as well. And then before the LLMs came up and the vector databases and vector embeddings, we kept on telling organizations, adopt a technology that is extendable. Do not adopt bespoke solutions. That doesn't scale. The number of data assets has exponentially increased. And then all of a sudden, vector embeddings became a big deal. And RAG LLMs, right, for generative AI. It took us 2 weeks to build a library for embedding with arrays. Why? Because a vector is a one-dimensional array. So we're going both ways. It's not, we shouldn't be thinking only about the past and all the legacy formats, that too. But what about the future? There is, I guarantee you, in the next 5 to 10 years, there's going to be yet another data type in life sciences and others. And people are going to say, oh, our current infrastructure doesn't handle it. We need to add another solution. Yeah, but that's exactly the problem. You're keeping on pathing things instead of completely solving the problem. And you can solve it only with a universal technology. There's no other way.
Right. Yeah, no, that's great. And that's where you guys are sitting. Are there other companies doing what you're doing that you know of or trying to?
So not exactly. So there are, the domain seed is very crowded, and we empathize a lot with our customers and our prospects and any other organization that is looking into technology, because there are thousands of solutions and there is a lot of noise. So we empathize with that. Someone may say, yeah, to an extent, people are doing it. Maybe Snowflake is doing it, Database is doing it. Not really. Like if you look into their infrastructure, it's not the same. We build it from scratch with foundational primitive. Usually, in order to be able to pull off what we're pulling off, you need to put together 10 different solutions. But that's not what we're doing. We're not an aggregator of other people's solutions. We have a single solution built from scratch. So a single solution, universal, built from scratch, which can handle tables and files and generative AI and genomics and transcriptomics and point clouds and so on and so forth. No. Why? Because they didn't want to build a universal technology. They wanted to build in a modular, incremental fashion yet another solution which complements the platform. That is not sustainable. It's not scalable. It confuses and it creates a very convoluted infrastructure for organizations.
Sure it does. Yeah. And like you said, you now can use that across. I mean, if different groups have different data structures, right? It's commercial versus R&D or whatever, right? You know, if they have different data sets that they're looking at, you can handle it, you know, and you can pull it into their analytical tool, whatever that is, whether it's AI, whether it's, you know, I don't know, Informatica, whatever it is, you know, doing their work or looking at something, right? You know, that's awesome. So let me ask you this. So, you know, you guys saw this, right? You brought it forward. You said you got a little lucky, right? With the AI thing, it kind of came into your wheelhouse, which is awesome, right? What are you seeing coming down the road that you think, you know, may help us here, right? In our industry, in the biotech industry, or what are you angling yourself towards to get ready for? What do you see certain folks needing to do or being able to do that, you know, TileDB is going to help us with?
I can only speak about our vision and our mission and what we would like the world to be like, right? Because other people may have different opinions and they may go about it in a different way. But I can tell you at least how I think a vision like TileDB can help organizations accelerate discovery, focusing on biotech. For the audience, TileDB doesn't just do biotech. It's just that this is of extreme focus in the next couple of years for TileDB because we see a lot of traction, we see a lot of importance, right? We believe this work is important. But TileDB is more universal, as I mentioned. But I will speak specifically about life sciences, and this can be extrapolated to other domains as well. Specifically in life sciences, I'll tell you the blockers for acceleration and for innovation and for realizing things like personalized medicine and other stuff like this, right? And discovery in general, like drug discovery in general. The first problem is the silos of the data in an organization. Like you have some of the smartest people I have met work in biotechs and big pharma and hospital, and they're completely siloed from each other. They don't collaborate because their solutions are different. A different solution for oncology, for imaging, different solution for bioinformatics, for genomics, different solution for single cell, different solution for tables, different solution for files. And they don't communicate with each other. For those more advanced organizations who spend a lot of money in infrastructure, they end up building massive teams, very big teams, who are trying to harmonize this. So instead of ripping the software and either building or buying a universal, holistic, singular data infrastructure, they're keeping those bespoke solutions and they're trying to build layers on top. That takes a lot of time, a lot of money, and it's not scalable because as soon as a new tool comes in, you need to integrate that tool. And then a new tool comes in, you need to integrate that tool. And that becomes completely unsustainable and extremely, extremely expensive. So, but those more sophisticated organizations at least have these layers. They're calling them data meshes. Some are calling them the modern data stacks. Like, there is a lot of different terms that people are throwing around. But again, these organizations that should be focusing on discovery, they're focusing on building infrastructure, which I find crazy.
Yeah, right. That's not their business.
It's not their business. It is equivalent. It's crazier the way I'm going to phrase it now than it is to say, yeah, big pharma is building infrastructure. That's crazy. Imagine TileDB, a database company, trying to find the cure to cancer with wet labs. But we're not a wet lab organization. But it's equally crazy. Why isn't it crazy to say that in a big pharma or any other organization for that matter, whose main business is not data infrastructure, they're building infrastructure from scratch? You should be partnering with organizations who are doing this 24/7 for years with deep expertise in the topic. And this is exactly what, again, that's the vision. There are different opinions. They may say, no, we really want to build the infrastructure ourselves because we believe it's IP. We will disagree there. The IP is in drug discovery, right? It's in the science, not in the data infrastructure. The infrastructure at some point becomes commodity. So that's not your IP. Cannot be the IP. People will, at some point, the technologies will converge, the performance will converge. That's not your IP. Your IP is in the science. We want to help accelerate the science. And we're seeing this, like organizations that could be trying to build infrastructure for years and years, they can take advantage of TileDB, and in a couple of months, they can be up and running. So you're saving all this time. So it's truly a game of time. Given enough time and money, the pharmaceuticals or anybody else will be able at some point to build something that is at the same level of TileDB or somebody else, like Snowflake and Database or somebody else. But in my opinion, my vision is that we need to go faster. If we're going to see in our lifetimes, we're going to see discovery of important breakthroughs, then we're playing not against each other, but against time.
So great. Why don't you tell me what you think or what you're seeing in the future for our industry, for biotech and such?
I'll tell you what my vision is with TileDB and specifically for the life sciences domain. We are up against time, right? Given enough time and resources, at some point, the technology is going to advance and multiple different technologies may converge around which one is better, faster, cheaper, but we're up against time. What we can do with TileDB is accelerating, right? Because the technology exists today, we believe we're ahead in terms of the features and the sophistication of the technology itself. And we can help organizations, as I mentioned before, avoid the silos, right? The silos exist, and this is what is blocking organizations. So we can de-silo the organizations, bring a holistic catalog, a holistic system, so that the organizations can view all their assets, all their data assets, and specifically in life sciences and biotech, these assets are very diverse. So have a holistic view of all of these, have a holistic governance across these assets. And then exactly because of the array technology of TileDB, for the most difficult data assets, we can put structure in them. And this structure gives performance, it expedites the analysis, and it brings the cost down. So this is how TileDB envisions to accelerate the discovery in these organizations, so that in our lifetime we see the fruits and we bear the fruits of these discoveries and these breakthroughs.
That's great stuff. I love hearing this because, again, everybody that I talk to, all these technology leaders that are running all this data are just stumbling on this, and makes so much sense. I even see a lot of these PE and VC firms trying to own the whole value chain, right? With data. I mean, they see data as the petroleum of our generation. And especially with AI coming on so strong and so big, again, data's the fuel that fuels it, right? So being able to pull it, like you said, is just incredibly powerful, you know?
Absolutely. And I do believe that organizations realize how adversely impactful the silos are, that every subgroup has its own data and its own solutions. I would just urge against particular pitfall. We have seen organizations realizing that the era of consolidation, of technology consolidation has come. And that's a good thing, in my opinion, because right now technologies are very fragmented in an organization, too much software to deal with. But you shouldn't be doing it in the wrong way. And the wrong way is to try to force feed unnatural data types in a single purpose-built database. Even a relational database is purpose-built. It's built for the purpose of storing tables. You cannot store an image in a table. You cannot store genomics in its entire complexity, into a table. You can't do that. You need something much more versatile. And this is what we're doing with TileDB. We're offering something that is much more flexible than a table and that can capture these modalities efficiently, not just with a half measure, in an optimal way or in a near optimal way.
Yeah, and scalable, which you've said 100 times today, which is everything you're saying. I mean, it's awesome. Again, based on everybody that I'm talking to. Now, let me ask you a question. I mean, we went through the technology, we went through some of the use cases there, but let's just say I'm watching this and I'm thinking, I'd love to work for these guys. Why would I want to work for you? And why would I want to work for your company? What separates you guys out from I don't know, somebody else, away from the fact that your technology is totally awesome and it's going to change, the way we do things.
You know what? Like I always ask myself and my leadership team this exact question for our own benefit, right? How do we retain all this talent? So what is it that we offer to our existing team before we promote this to people that we would like to take part in what we're doing? So this is a recurring question. We're trying our best, of course, for the answer to be awesome for our own benefit as well. I believe one of the most recurring themes is the sense of purpose. We are at the cutting edge of technology. We're building something new from scratch. We have assembled some of the smartest people on the planet, and I kid you not, excluding myself. Okay, I'm speaking for my team. Some of the smartest people I have ever met in my life work with us at TileDB, and we're building something meaningful, right? We're building something that could contribute in its own way to discover a cure to a disease, right? Or to detect a rare disease, as we're trying to do with Rady Children's Hospital at the NICU, right? For newborns, so that we save the lives of babies because we're going to take action on something that the data has revealed. So there is a huge sense of purpose in the company, and everybody knows it. And we make absolutely certain that we repeat this internally, that folks, this is why we're getting up every day, and this is why we're spending so many hours on this. So definitely the sense of purpose. The other thing is that, again, if you're into technology, I mean, it cannot get better than that. Like we're working at the pinnacle of technology. This is completely new stuff that we're inventing. In the very least, we're keeping ourselves up to date with other technologies as well, so that we're kept on our toes in order to be able to stay ahead. And finally, I would say the team. The team is remarkable. Like I can't be more proud about what we built with the team and the team that we have assembled. Like half of the team has PhDs, and this is not to say that we're not gonna welcome people without, but This is kind of remarkable. We're building technology here. We're not a research institution, and yet, and at the same time, everybody has amazing personalities. Of course, we handpick everybody, as you can imagine. But one of my proudest moments is seeing this company grow with these individuals. At the end of the day, the company is the team.
Yeah. And I think you said you're around 70 folks now or so.
About 70, yeah.
Is everybody based in Cambridge, or where's everybody located?
The headquarters are in Cambridge. This is where I started the company. We're fortunate, at least in my opinion, to be a remote first company since before the pandemic. So we got incorporated in 2017. The pandemic hit in 2020. So we were fortunate because the pandemic did not impact our operations whatsoever. And we maintained it. We never changed back to an office-only policy. We do maintain physical offices. We have one in Cambridge. We're about 6-7 people here. We have a newly created one in New York City. We have a big hub now growing New York City. We have a big presence in Greece. We have about 25 people in Greece and growing. And then the rest are kind of scattered all over the US and some people in Europe as well. So fairly remote, but we've been very good at making this work very well operationally.
Well, and I'm sure that helps you too, right? With your recruitment and with getting the best talent. It doesn't matter where they're located. They can get it done for you, right?
Indeed, that played very well with certain talent that we were very fortunate to hire. Whereas if we followed an office-only policy in Cambridge, it would have been quite difficult to get these individuals.
Right, right. Well, so another question for you, really about your technology. What makes TileDB's technology different? You know, if I'm a CIO, sometimes I might want to think about those things, and that's my audience, right? So take me through that real quick.
Yeah, I would say, well, at its core, I would say it's the multidimensional array as the universal data structure to put structure into what other people see as unstructured data and to make it more efficient, especially with complex data that is not immediately obvious how to model this data as tables, which are a little bit more common, or as blobs, as just flat files, right? So the multidimensional array definitely plays a very key role in TileDB and how we structure the data, how we obtain performance for complex and diverse data. But I would say the second thing would be the holistic approach we take. And we took this holistic approach since day one. We welcome all the data. And now we have a very important upcoming release early 2025, where this is going to be even more pronounced. We take a holistic approach to cataloging, to authenticating users, to controlling the access, to logging the data for auditability for all the data in the organization. And this is quite important. If you overfit your technology to capture one data type or a limited number of data types, you will find yourself in a situation where the organization will seek for multiple different solutions to satisfy their data needs. With TileDB and this holistic approach and the fact that it is future-proof, we're always there to welcome any new data type and make sure we optimize for it as well with the current technology without having to build a ton of technology on top of it.
I like that, future-proof. I like that. That's nice. So everybody's thinking about and everybody's talking about, the whole world, not just you and me and not just some of my CIOs, everybody's talking about AI, right? So, maybe you can give me a quick appear to me. I would think in my head that TileDB would play great with AI, right? I mean, how about that? I know you said, when you started this whole thing, right, that wasn't even really a thought, but now it is. It's got to be front and center, right?
Yeah, when I first started TileDB and architected around arrays, in my mind, I had machine learning, traditional machine learning, not what today the market is perceiving as AI, which is mostly large language models. AI is much more than large language models like ChatGPT. However, in my mind, I started with the more unsexy things, so to speak, like the data plumbing. I was convinced that I need to start from the foundation. And here's the reason. When you're creating machine learning models or AI models, you need to train those models on data. So you need to have infrastructure capable of this training. But this infrastructure is not just a file manager with a bunch of files and then some kind of a distributed computing engine to train the models. Like, you need authentication, you need governance, you need access control, you need to be able to locate the data, you need to be able to version the data, you need to be able to version the models. But you see, once you start adding functionality features, effectively, you're building from scratch a database, right? A database that could not satisfy your needs with the traditional databases could not satisfy these needs. So you need a new database for AI, effectively, right? For training the models, for accessing the data for these models, keeping track of which data you accessed to train these models, how to update these models. There are more things that come into the scene, like these so-called RAG LLMs, right? You need to create vector embeddings from data so that you provide context to these LLMs and answer advanced queries on private data that was not used for training the LLMs. This is what RAG LLMs do in a very simplistic description here. Well, but this is also data. So then now you have the vectors, and you need to store the vectors, to access control the vectors, to version the vectors. You need to be able to associate the vectors with the actual model. So now you have special metadata handling for this. So eventually, the whole AI space is a data problem. So it's not even a compute problem. Of course, a lot of compute is involved, but at the end of the day, it is a data problem.
Well, 75% of those projects fail, and it's because of the data. They can't, it's not working. You can build the sexy model. You can make it look nice, but getting your data, having your data right, like you just said, they're like, whoa, we forgot about this.
Yeah. You need the data infrastructure. Let me put it this way. You need to start with the data infrastructure, and then I believe AI can be a very important piece of that infrastructure built on top of the data infrastructure, which can provide a lot of value to an organization. But if you think about AI in a vacuum without talking about the data that facilitates all these models to be built and trained and versioned and evolved, I believe you will eventually fail.
Oh yeah, absolutely.
There is you will hit a data problem. It's not going to be the AI that is going to create issues for you. It's going to be something that broke on the data aspect.
That's what I'm hearing over and over and over again. That's why I'm getting so fired up talking to you about this stuff. This is great stuff, because I'm hearing about these problems all the time. So everybody I'm talking to could use what you guys do. Anyway, well, that was great. I appreciate it. If you have anything else to add, want to throw it out, because I have one final question I ask of folks, and I never tell anybody what it is. And it's one question that I ask everybody. It's the same question. But if you got anything more you want to add that we haven't hit on from either technology or whatever perspective, go ahead. And then I'll ask my final question. But if you don't, no big deal.
I think we covered good aspects of what we're doing here at TileDB. We're always open to hearing back from thought leaders in the space. We're having amazing conversations with them all the time, and we're prompting most of these conversations, but we're very happy to hear from them. Anybody listening in can find information about TileDB on TileDB.com.
And they can reach out to you as well, right? With any questions, yeah.
Directly, of course. Stavros at TileDB.com. I would love to exchange thoughts on this topic because this is serious. Like, it eventually affects lives. The way this technology is used or could be used, it can affect people's lives.
And whenever I'm talking to people, this is just what I do for a living, right? If someone tells me about, I'm going to be looking for, I don't know, I'm just going to make this up, a CTO that does X, Y, and Z. As I'm just out talking to people, I'm like, hey, somebody told me that they're looking for that. Same way as with what you guys do. If someone brings it up, I'll say, hey, you guys need to talk to Tile. That's just what I do. That's who I am. So anyway.
And we appreciate that, Steve. Thank you.
Yeah, no problem. No problem. But final question for you. I'm a music guy. I love live music. I love seeing bands. I love seeing concerts and things like that. So just to loosen it up at the end, I always ask folks if they have a favorite live band or a favorite live act, one that they've seen at any point in their life that they could say, you know what, that was good. Or if you haven't, that's fine. If you were too busy building your databases, I get it, So, but if there was ever anything that you can say you saw that the best live show you've ever seen, or if you don't see many live shows, you're too busy doing your thing, then it is what it is.
It's definitely not about being busy. And if any of my friends listening would laugh at this point, because they will know that I'm not this kind of a person it's not one of the things I do. Let me put it this way.
Okay.
However, I have attended live music festivals and bands, but I will trace it back to my teenage years when I was listening to to Greek rock like Tripes, for example. and
Okay,
again, if
perfect.
any Greek is listening in, they would smile.
They'll get it. Yeah,
They'll get it.
they'll get it. I've had a bunch of folks talk to me much older than you and I on my podcast, mention stuff from when they were 13, 14, 15 years old. You know, those were their favorite live acts.
And don't get me wrong, I enjoy it a lot. It's just that I don't do it. I can't explain it.
That's fine. Yeah, some people don't like it. I can't
explain it. But I liked it. You
spend your time and money elsewhere, right? You know? Yeah, you spend your time and money. That's what.
It's a great question, though, Steve. What is yours? What is yours, by the way? I don't know if you shared it on another podcast, but maybe I'm the first one asking. What is your favorite? You are
absolutely the first one that's asked me. 100%, man.
Everybody's neglecting the host.
If I had to say my favorite live act ever that I saw, I really liked watching the Allman Brothers Band. Those guys could play guitar. They were just great musicians. And it's amazing to me how 6 or 7, or in their case, 8 or 10 people on stage can play so tight in one song and all be playing different instruments at the same time. You're like, are you kidding me? You know, it's like they know where each other's going to go. Probably like a bunch of great computer programmers, right? They know, and I'll be honest with you too. Show me a good musician, I'll show you a good computer programmer, right? I mean, that's kind of the same. But yeah, I'd say the Allman Brothers Band. That would be mine. But it's funny. Again, nobody's asked. Nobody's ever asked. Nobody. So thank you.
This is great. This is very interesting.
Yeah. Well, listen, I appreciate your time. That was great. Thank you very much.
Thank you, Steve. Thank you. I appreciate the opportunity. It's great. Great to talk to you.